Now let's take a look at the other special triangle, the 30, 60, 90 triangle. Well, how do we get a 30, 60, 90 triangle? Well, we get it by taking an equilateral triangle, like this one, and splitting it in half. So, again, I'm going to make this triangle so that the sides are one unit, so that when I put it over on my unit circle, it matches up. So each of the sides would be one unit. What happens if we cut it in half to make this 30, 60, 90 triangle? Well, we find out that this other side ends up being 1/2. And how do we go about finding the length of this hypotenuse right there? Again, we can use the Pythagorean theorem. However, if you're familiar with a 30, 60, 90 triangle, you know that no matter what the size is, that this side is going to be half of that side, and this hypotenuse is going to be the square root of 3 times whatever the short side is. So in this case, this side is going to be the square root of 3 times 1/2, which gives us the square root of 3 over 2. So now what would happen if I was to take this 30, 60, 90 triangle and put it over here on our unit circle? So I'm going to go ahead and transfer it over like it is right now. I'll do it in a different color. But we'll end up with a 60-degree angle, which ends up being from there to there. Notice that that's going to correspond with this length here, which is 1 unit, which makes sense because we're on the unit circle. Well, if I was to create that right triangle, what's going to be our horizontal length and what's going to be our vertical length? Well, the horizontal length is going to be 1/2, and that vertical length is going to be the square root of 3 over 2. So if I'm going to look for the ordered pair, our x value happens to be that horizontal length, so 1/2, and the y value will be that vertical length, which is the square root of 3 over 2.